Hi, calculus. Well, looks like I'm still at home. So you're in school. Oh, I guess that's a switch from last week. So I put together a little review for us before the smaller quiz, not a big test that you're having today. So I picked out from 112 an IVT problem to review, some limits, and I picked a couple extra limits, and a continuity problem to do a little bit of review for those. So sit back, relax, and enjoy those before your quiz. After the quiz, there are some worksheets for the weekend with derivatives. We're starting chapter 2, so hopefully some short things right before fall break that you can get done. Those note pages and worksheets are on Schoology, so you'll have to print them yourself. When I'm back after fall break, I'll get you the entire chapter for chapter 2. All right, take a look at the review here, and good luck on the quiz. All right, calculus, here's some questions that I picked out. From 112, number 7, review of the IVT here. So intermediate value theorem. Show there's a number, C, in 0 to 1. Those are our x values. Such that f of c equals 1. We're looking for an x value in there when we have our function. Okay, nice polynomial there. So how do we find that there is some number within there where the y value will be 1? So remember the intermediate value theorem, when it says show or explain, we have to check the conditions. So condition number 1, remember, this is just a statement. We don't have to do a proof of it. First thing we have to know is continuity. We have to know it's continuous within the interval. So if we look at this one, it is a polynomial over here. Polynomials are continuous, so we just have to state that. So condition number 1, f of x is continuous on the interval 0 to 1. Okay, you don't have to say how you know or do a proof. You just have to check it in your head and say that. If it's not continuous, say it's not continuous because there's something going on. There's a hole, there's a removable, or there's a jump at a certain place within the interval. But this one, it's continuous. That's our statement. Condition number 2. Condition number 2 is to show that the y values fit. We want a y value over here of 1. So we have to know the y values at the endpoints. So we are going to show f of 0 is, this is 0 minus 0 plus 0 is 0 when you plug that in. And f of 1 is, let's be 1 minus 3 plus 6 is 4. So we are checking for 0 is less than 1 is less than 4. Make sure that 1 is between 0 and 4. That's our second condition we have to check. Show the values on the end. Show that the number you're looking for is between those values. So 1, 2, we have shown those. We're good. We can go on. So IVT will apply. And now to find that C value, we have to just say 1 equals, that's the number we're looking for, the equation, x cubed minus 3x squared plus 6x. Okay. Now, to solve this one, this is not an algebra problem you could solve on the quiz. They're all problems you know how to solve. This one would take a calculator. You want to set this equal to 0. We've got x cubed minus 3x squared plus 6x minus 1. It doesn't factor. That's our problem. Not normally. So this one, you can use your calculator and find the zeros on this. Now, there are a few zeros that you will find if you do that on your calculator. We only want to find zeros, since I made it equal to 0, in the interval 0 to 1. So you don't have to look everywhere. Okay. Remember, we have to find a C value within this interval. If I give you a C value, my C value is 5. That doesn't work. That doesn't fit where we're guaranteeing there is one. So there's got to be one between there if the two conditions have checked out. All right, on this one, when you solve, You get like 0.182. C is 0.182 when you solve. Like I said, anything that you will have to do on the quiz, you know how to solve. Just quadratics or something like that, or just doing some simple algebra to solve something you can't factor. All right, that's a little review of the intermediate value theorem. Make sure you can show the two conditions, make those statements, and know how to solve if it's possible, if it's guaranteed. Number 13, a little bit of continuity, just reminders on this. So this one says, is it continuous? If not, where are they? And are they removable? Or really what kind? We should be able to tell. So if you're given a piecewise like this, things you need to check. We definitely need to check what's going on at 3. So that one is kind of our, is it a jump in there? Is it a removable maybe? So let's check that. But don't forget to check each equation on its own. Okay, there could be vertical asymptotes or holes within these if they were more complicated. So the first one, x plus 2 is a line, that's continuous. 6 minus x, that's continuous. So we're good with those. Okay, watch out for denominators. If you find a hole, make sure it's within the domain, that it'll actually show up when you're trying to graph it. So how do we check this jump? For 3, we are going to check both x plus 2. 3 plus 2 is 5. For the 6 minus x, do that one. 6 minus 3 is 3. So because of those two, we definitely have a jump discontinuity when those are different. Okay, remember, removable in this case would be if these came out the same, that means they're trying to connect. But to be removable, you can't have an equal sign on this. Okay, so if the numbers are different, it's a jump. If they're the same, then check if the actual point exists. So this one is a jump discontinuity at x equals 3 is all it is. Okay, but it's okay if there's more than one. Sometimes we find these with more than one. If there's no discontinuities, you can just say it is continuous. And some limits that I picked out. There were just a few. 17, 18, and 19 kind of take us through the progression here of infinity limits. This is one thing that I noticed from the last quiz. So the rules about infinity limits here. First one, when it goes to infinity, we are comparing degrees. Degree 1 on top, degree 4 on the bottom. If the bottom is bigger, remember that horizontal asymptote is the x-axis. That automatically means it goes to 0. You have bigger numbers on the bottom. Okay, bigger on the bottom goes to 0. The next one, again, limit as x goes to infinity, so we're using those horizontal asymptote rules. 4th power on top, 4th power on the bottom, same power. Same power is a ratio of those coefficients. Really, we can get rid of everything else that wasn't the highest degree. 3x to the 4th over 5x to the 4th. Okay? That cancels. Really, that's why we just have the ratio of coefficients. So this one is 3 over 5. I could have worked over here too. Just put 3x over 5x to the 4th. Reduce it. You get 3x over 5x cubed, or not 3x anymore. You just get 3 over 5x cubed. And if we look at this one, that's going to be a number over plugging in infinity. We have a bigger number in the bottom. That makes a 0. This one they cancel. You just have 3/5. Number 19 then, bigger in the numerator, 6 and 4. This one is a slant asymptote, or technically this one is even like a parabolic asymptote. So instead of going through the whole division, do the same thing. Compare the lead terms, 10x to the 4th on the bottom. This is x squared over 10 is what that reduces to. Or we could say that is 1/10 x squared. What you're looking at here is the x squared is in the numerator. This is just a polynomial. This is a parabola. That parabola goes up on each end. So as x goes to infinity, there's our answer, infinity. Okay, so the lead terms are what is important on these. Once you understand the lead terms, they'll kind of work out to go through the same idea. Number 21, don't forget about these trig functions, sine and cosine. If we're going to infinity, sine is highest is 1, lowest is -1. So plus or minus 1 is all that can be up on top. and e raised to a big number is a big number. So this is a stable number, plus or minus a 1 over infinity, which is 0. Okay? Doesn't matter if it's positive or negative. It narrows down to 0. This one actually has a little horizontal asymptote, but it keeps crossing it. It goes like this. Okay? It keeps getting smaller and smaller. All right. I picked these two off of another worksheet because we need a little bit more practice here. So when I give you a number, you plug it in. You guys did pretty well with the 0 over 0 idea and reducing, but this one, plug in a 3, you get 3 minus 2 is 1 over 3 minus 3 is 0. So let's think through this. 0 in the denominator, without being in the numerator, was a vertical asymptote. That vertical asymptote, we have choices. Do both sides go up? Do they both go down? Or is there one in each direction, one up and one down? So that's our choices. The first power on x minus 3, the vertical asymptote, gives that away. That means we are in different directions. So that means our answer is, so the odd exponent is what we looked at. Answer is, does not exist. Okay, one goes up, one goes down. They're going to disagree with each other on the direction. So that one, the full limit, does not exist. Now, if I ask the same question, do 3 plus right here from the right side. Now, I just drew a sketch down here. And now I need to know which side is which. Is it on the right side, is it going up and then down on the left? Or is the right side going down? So which one is it? So there's a few ways you can do this. You can do the number line chart and compare the pluses and minuses. That would be fine. You can plug in a number a little above 3, like 3.1. Remember, all we're trying to do is figure out positive or negative is the only thing. So we already said if we plug in 3, we get 1 over 0. Okay, that's a positive 1. 3.1 minus 2 is just going to be 1.1. It really doesn't change that much. But on the bottom, instead of 0, it is 0.1. It's positive. That's what we need. So really, we're just checking which side of the 0 we're on and then putting it into the equation. Both are positive. That means that answer is positive infinity. So number over 0, check the vertical asymptote and see which way it's going. All right, that was a little quick review, a little bit shorter quiz today. Good luck on this one with some of each of these kinds that I just went through with you. All right, good luck. Have fun with that quiz.